Hey guys, okay, so this is week 13 science, and this is experiments number 161 and 162 in the Van Cleve's 201 Awesome, Magical, Bizarre, and Incredible Science Experiments. I'm actually going to demonstrate number 162 first because it requires that you wash your hands and don't get oils from your fingers, and so I'm just going to go ahead and do this and get it out of the way. This number 162 is called humming glass, and this is where we are going to demonstrate using your finger and the friction of a glass, stemware glass, to make a humming sound. So the first thing that it says to do is to wash your hands and the glass with some dishwashing liquid. Right here I have, this is actually water for crystal. I don't think I'm going to be bringing this on Community Day, but I didn't have any less expensive ones. So between now and the time that we do this, I'll hit some thrift stores and pick up some more inexpensive glass stemware. But any glass should work as long as we do it. As long as we do it this way. I'm just going to illustrate for you the procedure. So first it says use the dishwashing liquid. I'll make sure that I have some there for you. To make a warm soapy solution, you basically wash your hands and the glass with the dishwashing liquid. And then you rinse it really well. And then you're just going to set the glass, in front of you on a table. Then what it says, and I'll have these little plastic cups for you, is to pour a thin layer of vinegar in the cup. And we're going to hold the glass base against the table, dip your finger in the vinegar, and then just rub it along the rim of the glass. So you can hear the humming sound when you're rubbing your finger along the edge of it. And basically what happens is the book is explaining the vinegar dissolves any oil that might be present. And so it increases the amount of friction between the top of your finger and the glass rim that you're using. Rubbing your finger around the rim causes the glass to vibrate, and that's what causes the humming sound. So vocabulary or concepts that we could introduce here, friction, frequency. If we were to use thicker or thinner glass, we would get a different vibration. If we were to use more pressure or less pressure, we would also get a different frequency. We can talk about vibration. We can talk about sound waves. We can talk about the parts of a sound wave. So all of those things are concepts that we can introduce depending on whether you've got the youngest kiddos or the older kiddos, and then in between. Nicole Liam, NicoleLiem on CC Connected, has wonderful write-ups of all of the science experiments, and she on this particular one has an image of a sound wave, and so she talks about the different parts of a sound wave and what makes a sound higher pitched or lower pitched, higher or lower frequency, and she kind of explains that too. So especially if you have some older kids, maybe that would be helpful for giving you some talking points or some things that you could help them put into their science journals. So that is number 162. Like I said, I'll provide everything that you need. I'll just make sure we've got water and dishwashing liquid in a bowl. Probably only the first 2 science classes will need to wash the glass, but everybody will need to wash their hands. It's up to you if you want to let your kids participate or if you just want to demonstrate and then have them put sound waves or frequency information or draw a picture of the glass in their science journals and explain what's going on. The second experiment for this week is number 161. It's called Spoon Bell, and the purpose of this experiment is to demonstrate what makes sound loud or soft. And so what they've had us do is take a metal spoon and then tie some string around the middle of the spoon. So you want to try to get it around the middle. Doesn't have to be exact, but the closer to level it is, the easier this experiment actually is to do. So you're going to cut a piece of string and tie it around the spoon, and then what you're going to do is you're going to wrap the ends of the string around your index fingers. So just once or twice around will be fine, and you can hold it with your thumb too, that's fine. But you want to try to make it about even on both sides so that when you hold the string up, the spoon dangles about level. And then what you're going to do is you're going to put your fingers in your ear. And I'm sitting here at a table, so actually, I'll show you with the chair. You're going to just barely tap the spoon against the table or the chair or whatever it is that you're using, and then take note of what you hear. And then you're going to do it again with a little bit more force so that you get a louder sound. So I'll show you what I would do. If you can see this on the computer, I think you can. So I'm going to have my fingers in my ear, and I'm just barely going to tap my wooden chair with the spoon. And I can hear a sound. It sounds like a dull bell. But now if I let it swing a little bit harder, I get a much richer sound, and it's louder. So that's basically what the experiment is. If you've got younger kiddos, you might want to leave the string on your fingers, if you don't mind putting your fingers in their ears. Then you can put your fingers in their ear, and you don't have to worry about messing up the string or the spoon or anything, getting it coming off, but then they can still hear what's going on. Older kids, obviously, you could let them maybe do this experiment in pairs. I'll have extra spoons and extra string, so they will be able to do that. Again, some concepts or vocabulary that you might want to introduce, things like sound. What is sound? What makes sound? Vibration, amplitude, how loud or soft sound is. And then also, especially for the older kiddos, because sound is a vibration, how does the molecules through which the sound is traveling impact the sound? So if I have sound traveling through air or sound traveling through water, why is it different? If I'm above water, why does sound differently than when I'm underwater? So things like that, molecules, number of molecules in a solid versus a liquid, air versus water, that kind of thing. Again, Nicole Liam on CC Connected has a wonderful write-up on this, so there's additional information about frequency, about the distance of molecules in solids versus liquids, and that kind of thing, also on vibration. So hopefully that is helpful, and hopefully this will be a fun experiment.